Hey everyone, welcome. I am absolutely thrilled to guide you through this explainer today. We're going to learn how to uncover the hidden layers of the internet like a true digital detective. Today is all about advanced search strategies. Now, if you already know your way around a basic search engine, but want to level up and learn how to conduct highly structured, efficient research, you are in the exact right place. We're going to break down how to locate publicly available information using open source intelligence, or OSINT techniques. And we'll be building this from the ground up with a major emphasis on the ethical, legal, and responsible use of these incredibly powerful tools. Let's dive in.
Here's our roadmap for today. We'll start with the basics of OSINT, move on to a professional intelligence lifecycle, and then arm you with some serious search operators and archiving tools.
Section 1. Welcome to OSINT, moving beyond basic search. So to kick things off, we really have to recognize that the normal way most of us search the web, it literally just scratches the surface. Most people type a random question and just kind of hope for the best, right? But we're going to take total control. The crucial takeaway here is that open source intelligence, or OSINT, relies entirely on publicly accessible information. We're just using highly structured methods to find data that isn't easily visible through casual everyday browsing. And as a fundamental rule of this discipline, we observe, we analyze, and we respect limits. We are never, ever bypassing passwords or security controls. It helps to think of OSINT as just one piece of a giant intelligence puzzle. It's a team effort. You've got SOCMINT monitoring social media to gauge public sentiment, or FININT following the financial trails to uncover fraud. As digital detectives, understanding that OSINT works alongside this broader intelligence family really helps us approach our own research with that same professional rigor.
Section 2. The intelligence lifecycle.
A structured approach to data. Before we start throwing complex search commands around, we need a game plan. True digital detectives do not just guess. They follow a highly structured approach so they don't end up drowning in irrelevant data. The open source intelligence cycle is actually a continuous loop. You don't just randomly hoard information. You plan, process, analyze, and refine. Every piece of raw data you uncover feeds right back into your planning, making your very next search even more precise. Let's break those steps down a bit. First, you have to define your scope and objectives. What exactly are you trying to find? Then, you collect your data from public sources. Next comes processing, which means organizing and cleaning that raw data. This could be as simple as formatting a messy spreadsheet or translating a foreign website. Then you analyze it all to identify real patterns and separate the facts from the noise. And finally, dissemination, which is just a fancy way of saying you share your findings securely. All right, Section 3, Mastering Search Operators. Let's learn how to communicate directly with the crawler. First up, you've got to understand your tools. Standard search engines like Google or Bing send out automated software, crawlers, to scan the web and save what they find in their own massive proprietary databases or indexes. But here's the thing, they cannot index everything instantly, so there are real limitations on search freshness and coverage. Meta search engines, on the other hand, don't even have their own indexes. Instead, they send your query out to multiple different search engines at the exact same time and aggregate the results, giving you a significantly broader view of the web. Take a meta search engine like Carrot2, for example. It is absolutely brilliant. Instead of just giving you a flat, boring list of links, it aggregates the results and organizes them into these fascinating visual topic clusters. If you're an investigative journalist or maybe doing deep academic research, this visual approach dramatically speeds up your ability to spot patterns and filter out all that extra noise. Okay, let's talk tactics. These advanced search operators, which are often called Google dorks, let you laser focus your search using Boolean logic. You are essentially bypassing normal website navigation and talking directly to the search index. For instance, the site operator limits your search to one specific domain. The uppercase OR operator tells the engine to find pages with either one word or another. You can use a simple minus sign to act as a not operator, literally excluding specific words to clean up your results. And you can wrap terms in quotation marks to force the engine to search for that exact phrase. The real magic, though, that happens when you start combining these techniques. Say you want to restrict your search strictly to a target company's website. You'd use the site operator and then combine it with in-title to find specific words hiding right in the page headers. This targeted strategy is infinitely more efficient than blindly clicking through menus. Just remember, a super common mistake when troubleshooting a poorly written query is simply forgetting your quotation marks. That'll break your entire search expression. Section 4, Digging up files, uncovering hidden documents.
Often the most valuable intelligence isn't sitting on a standard web page at all. It's buried deep inside a raw data file or a report. By using the X or file type operator alongside common extensions, you can instantly locate spreadsheets, presentations, text files, or huge compressed data dumps that are just hiding in plain sight. And notice how you can use that Boolean OR operator we just talked about to search for multiple variations of an Excel file, like XLS, XLSX, and CSV, all at the exact same time. Let's look at a practical example. Running a file type query for a Word document combined with the word resume and a specific target's name might actually pull up a publicly indexed document, one that contains personal phone numbers and a home address. Now, it's highly likely the author never intended to broadcast that to the entire internet. But because it was hosted on a public domain, the crawler grabbed it and indexed it anyway. This is a massive lesson in digital footprint management. Just because something is publicly discoverable does not necessarily mean it isn't sensitive. Sometimes you'll discover that certain publicly accessible pages or directories don't even appear in a website's normal navigation. You can use these search operators to locate open directory structures, like navigating directly into a public FTP server folder. This bypasses traditional search results entirely and can open up absolute treasure troves of public documents and manuals. But again, I really have to reinforce this distinction for our methodology. We are strictly discovering publicly indexed open directories. We are absolutely not bypassing passwords or accessing restricted private content. Which brings us to Section 5, archiving the web, because honestly, nothing is truly deleted. We've all faced this frustrating problem. What happens when the page, image, or data set you need has suddenly been taken offline? Well, you have two amazing backup options. Now, this is totally different from your local browser cache, which just saves images to load your favorite sites faster. Search engine caches are temporary snapshots saved by the standard crawlers. They are perfect if a page was just taken down a few days ago. But if you're doing deep historical research, you need to turn to web archives, which are dedicated platforms that take permanent historical snapshots over many, many years. Just look at the legendary Wayback Machine run by the Internet Archive. It has preserved over 300 billion web pages. It literally allows you to travel back in time to view a website exactly as it looked a decade ago. Whether you're a journalist tracking a company's changing public claims or doing cybersecurity research on a defunct domain, this tool is absolute proof that on the internet, nothing is ever truly gone. So, as we wrap up today's explainer, we've covered a ton of ground. We've reviewed how to plan out a structured search, how to combine complex Boolean operators, hunt down hidden data files, and even resurrect deleted web pages from the archives. But before we go, I want you to really think about this final question. What publicly available footprint are you currently leaving behind? Because as you've seen, once information is public on the web, a skilled digital detective using these methodologies can almost always find it. Thank you so much for joining me today. Keep practicing those search combinations, and I'll see you in our next lesson where we'll dive even deeper into archived websites and internet history.